Hello and welcome. I'm Bill Wake. We're here working on a parser. Basically, we're doing an example of evolutionary design, and we're in the process of converting an interpreter to use one parser instead of another. We're at the point of, we've done about half the statements, and we're going to do the rest today. So our goal is evolve this basic interpreter from recursive descent to parser combinator. And we're using the strategy pattern. It's not actually showing up much in our work, but we did some setup the other day. So there's now a class that creates a syntax analyzer, and syntax analyzer holds onto a strategy, and our strategy is one of the two methods of parsing, the old parser or the basic parser, which is the new one. And the core of this is that the syntax analyzer calls strategy, but it doesn't care. It's set up with one or the other, the old parser or the basic parser. When it wants to do one of the methods on that, it calls through the strategy object to get to it. So based on how we decide to set up the parser, we can either be running the old one or the new one. Now, in our case, we took the old parser and just cloned it to start out the new parser, and we're able to make every step along the way work. You know, all the old tests run, all that. It's just some stuff is being done the old way and some the new way. When we're done, everything will be the new way. Now, sometimes it's more like a branch that, you know, you're starting from scratch on the new way, and you can't really run all the old stuff until everything's ready. We don't have that in this case. All right. So, yeah, green check marks are ones we've done. We're down to input on the bottom there, in progress. And I've realized I made a mistake on the go-to. We deleted something that wasn't needed by the parser itself, but our test of the wrapper function dealt with it. So let's go deal with that first. Okay, yeah, so here we reference basic parser.goto, and we just deleted that on the last check-in, so apparently I forgot to run tests after I deleted dead code. Okay, and I think what happened was I was searching for goto with parentheses referencing that, but this is just referencing the function name itself. So I think the easy way out would be say, you know, our wrappers have worked so far, we don't need to test it anymore, and let's just drop this, because in the end, we're going to drop the wrapper and the test. The second easiest way is, I think, we can pull, let's see, do we have it in here? We can pull the go-to. Let's see, this one. Go to parser. Go to parser. Well, that's not doing it. Probably down here. Go sub, go to. Okay, so I'm just going to take that code and drop it back in the parser. Let's put it down in here somewhere. Okay, and I'm going to rename this. Well, let's make sure our tests run. All right, good. Let's check that in. Put goto function in for testing purposes only. I want to rename this. recursive descent example method for testing. Okay, and I'll just leave a to-do. Delete when the wrapper test goes away. I don't put a lot of to-dos in, but projects like this, they kind of bring them out in me. All right, once again, we'll make it run. Okay, and we'll check that in. All right, and I see there's something a little goofy. Okay. There's a bug in OBS. All right, so we were there, and then we were working on input. Let's see where we are with input. I think the method is called doInput. Okay. Let's see who calls this. Nobody. Okay. And let's find the input parser. Go sub if in input, and we're using it here. Okay, so this is dead code. Whoops. Move that over here. Clone one of these. Okay, so we're done with input. I want to put us on pause a minute on this project. The one that I think I'd like to fix this. We're using peak. Basically, we, for some of these parsers, where are they? We're using peak, which verifies that you've got a certain token, and we have to do that because it's basically an assumption. The old way assumed there would be one token ready to go, and the when then looks for it, and then the old can take advantage of the fact that token was already parsed, but we need to actually match it to know which branch of the alternative to go down. The let assign or do next they're not aware that they had an actual next keyword in front of them, but they need it from in terms of the matching. And one of the things we did, let's find that peak again. So we do peak. It takes another parser, runs the parser. If it fails, it returns the failure. If it succeeds, it just returns a hard-coded 0. And I realize now that it would actually be kind of nice if it returned the thing the original parser returned, but it doesn't make any progress on the input. So it says, here's the object you would get, and I'm leaving the input so you can reparse it or carry on or whatever you want to do. And right now we just return a 0, but if I had an actual the token back, I could check that it's if it's a line number, I can check that it's in the right range and things like that. So this is just an enhancement there. So let me switch into that project. Okay, so the peak upgrade, peak parser runs the parser, returns success or failure, doesn't consume input. That's kind of a key. If successful, it just returns a 0 that you can ignore. And instead, let's return the value the parser does, and you can check it further. Okay, and the project, let me bring that back. Okay, the other thing we had in here, there was a bad explanation. What was it on? Alternative? Yeah. If the first parser succeeds, it returns that result. If it fails with no progress, it returns the result of the second parser. Okay, good. If the first parser makes progress but failed, it returns the failure. Okay. And then alternative and name sequence. Optional repetition. Okay. And then I think not bind, but check is really an example of the previous thing. So let's move that up. Pipe and check. Okay. And then run the parser. If it fails, return failures. If it succeeds, return that value, but with untouched input. This lets you fail early rather than go down a long but incorrect path. That seems correct. And peak bind. I think we'll put these a little bit alphabetical. There's no real pattern. Not like the operators where they don't have a natural order. Okay. I think that explains that. And then let's go to the peak test. Okay, returns failure, yes, but I think check success, this should return whatever that returned, which should be a 1. Okay, so it returns the 1, but it doesn't consume any input. We've still got 1, 2. This test will fail now. Okay, and let's go to the peak parser. I guess I can just do this. Peak. Okay, so it takes a parser. Its target type is going to be p.output now instead of just that. Whoops. Instead of just that hard-coded 0. p.target. Okay, and success. Well, it's really success with let target, and we'll ignore the remaining because we're going to hard code this coming back. Okay, so instead of a 0, we're returning the target returned by this parser. And all tests should pass. Maybe another test that depends on peak. Nope. Okay, good. All right, let's commit this. Oops. Let's just do further checking on it. Cool. Okay, so let's see that. Now we need to do another release. We need to do a, I guess we need to label it is the thing. Okay, so let's label this. I think 0.2.2 should be okay. I'm not worrying about semver at this point because we're kind of pre 1.0, but we'll include tags and push and stop there. Okay, so here we are. We're back in our interpreter, and let's upgrade this. Update package. Okay, that seems okay. And let's take a look at peak. Just convince ourselves. Yep, there we are. Okay. And run this. Okay, the peak didn't hurt anything. All right, so let's see. We've got updated P combo library to get new peak. And I think it was just an opportune moment. It's not going to affect us. The old version was fine. It's just seemed like a good time to do that since we're between statements. Okay, let's see. Back to the parser. Okay, so we finished input. I don't know. Let's look at let. Let. Oh, that's going to be bad. Well, probably got to be matched somewhere. Okay, let assign. All right, so let parser equals match let, keeping the right. Okay, this is interesting. All right, so here I think we're peaking. Okay, let's see the test for this. Text. I don't know if I care. Let's see. The real thing is we're doing a RAPL on assign. This thing of passing something in kind of complicates the world. I don't think we need it. We try variable. Okay, let's back it up a stage. Okay, who calls this? It really should be two places. One is the let statement, this thing, and the other is just a raw assignment. You don't need a let. You can just say x equals 3 plus 2. Okay, so it's a variable. We're digging out the name here too. That tells me we could just let assign dig out the name itself. Let's take care of that then. Okay, so I'm going to say ignore that string and let name equal token.string. I don't even know if I need that. Okay. It's got that implicit exclamation point, and it's still optional. Okay. Yeah, sometimes it needs it, sometimes it doesn't. All right. So doing this, I'm ignoring the string I'm passed in, and I'm looking it up on the token, which seems like the right place to find it. Build. Oh, yeah, well. Can't leave junk there, I guess. That's fair. Okay, so make do assign no longer use its argument. Okay, and now I'm going to take that argument off. Yeah. Take the argument off. Compiler will tell me where I need to edit. Assign name. And since we don't do this, we don't use it. Okay. So return, try, assign, all that stuff is really the same as wrap old assign. Like that. Okay. Okay, let's go back into this. So now you match a let. And we want to do wrap old assign. And then I think if that fails, string parameter without target. Oh. Self-assign. Okay, back up here. Input, and this is let. Variables token type, try assign. The unfortunate thing, I guess, okay, we'll want this message shortly. I don't know what message we'll get. So I do think something should pass and something should fail in the let. Everything passed. Okay, where's do assign? Oh, just assign. Let's find let text. I'm sorry, how does that test pass? Oh, we're not calling it. Okay, I'll get there. Let parser. Okay. Now, like I said, I expect something to pass and something to fail. Okay. That is not the failure I expected. All right, let's see what test we're in. Basic parser test let missing assignment. Okay. Well, that's the one I didn't think I saw how it would get there. Okay. And how do the others do? Some ran. Nothing else failed. Okay. Let's see if we can make this. I think what we can do. I think we can say, if you don't succeed at the assignment, then we get this message. Okay. So should. No, there's something else going on here. Unexpectedly found nil. I think we need to push something down. Where's our let? What was it? Let assign? Okay. I guess we're going to have to push this in there. The thing is, the other case, the only way you get in there is if the variable, the token type is a variable. So let's move this down into sign. Okay. If case variable is not equal token.type, then do this. Require an initializer. All right, let's try again. Okay, now this is puzzling to me. I mean, I guess we're still going to have to deal with this. But maybe that'll work out. I think we're going to go through the same process. Okay. So let use new parser. I probably should do it this way. All right. Oh, and we were here. Now let's do the next. Okay. Oh, we should be able to delete this. Is this accurate? Convert remaining statements. Let's keep track. Oh, September 1st. All right. Well, fix, restore, go to method for test, wrapper tests. input and let, and we updated peak combinator to return the parser's value rather than just 0. Okay, I guess I could kind of move that up. Okay, convert remaining statements to new parser, and we're working on next. And we fix that documentation. Okay, and okay, so we're working on next. Oh, let a sign nobody's using, right? Okay. Okay, on. I thought I had a next. Do next, okay. This one, let next parser equal. We got to match next, and we just need a variable. Wrap old self require variable, and then pipe that. So let's arrange this a little more. Return, well, we only need return when it's the only thing. We just need to do statement.next with $0. Is that right? Variable equal try require variable. Okay, yeah, looks like that's all we're doing. Next parser. Should be using it. And let's get rid of this dead code. I thought we did 4 already. Yep. Okay, I think that takes care of next. We'll do on, which is a computed go to or computed go sub. this thing. Yeah, this has a little bit of complexity to it. Okay, so the on parser, we got to match the on. And then, so it looks like on some expression, go to, and then some line numbers, or go sub some line numbers. Okay, so this is expression, which is wrappled self expression. And then followed by a match go to or match go sub. And we'll put this in parens because otherwise the ampersand has more precedence. Okay. Go to or go sub. I think we'll leave off the error message, but it's going to be there. Okay. And then yeah, this is definitely a trickier one. Okay, match the on expression, go to, and then it should be line numbers. Okay, it should be integer. And match integer, otherwise we get a message. On requires at least one line. I think this message is probably gonna change. Okay, and then so we match those things. Line numbers are gonna be the tokens, and then we have basically it's a comma list of those. See, I don't think we're gonna get this. We're gonna get a unified message that covers both these cases. Okay. So you match an integer, and then it's separated by ignoring match comma. Okay. That gets us the array of tokens. It gets us a complicated thing. Excuse me. All right, so it gets us an expression and a go to or go sub in a pair, and then that whole thing in a pair with the list of integers. And then we got to turn it into a statement. All right, so the list, this thing, I think we want to parenthesize this, nest that, and then the whole thing, we're going to do something, and then close that. Okay, so what are we going to do with those tokens? So it's a bunch of integer tokens. We need to convert them to the float value, the line number value. Line number token to float. Okay, so this is array of tokens. So tokens.map, and the map is line number of $0, which is the token.float. Okay, so this turns this into an array. Expects one argument which cannot be ignored. Oh. I guess that's tokens in. Okay, so given the array of tokens, map each one to the corresponding line number value. Okay, so now this whole thing is, I guess it's this. Okay, so it goes to pipe 2, and then it's going to have I think I go through this every time I expect it to have things, but it's going to have the expression keyword, expression and go, and the line numbers. Okay, so line numbers is that, and this in this, and then we have to pull out the expression and saved token equals x per go. This returns a statement. Okay. Huh. All right. Match the on, match the expression, match either go to or go sub, match a list of comma separated list of integers, convert them to line numbers, and then take the expression, the go to, and the line numbers, and decide which one of these we're doing. I don't know. Is this better? Save token equals go to. I don't think. Yeah, I don't think I can write it any better. Now, what else is going on here? Has no member go to. Or else satisfy this has no member go to. Let's build to make sure it's just not confused. Type or else. Satisfy token dot target, aka token. Oh, save token dot type is go to. And actually, that was a good instance where, see, we have these horrible nested types, but it works out and says, okay, if it's an or else and it's satisfy token, and their target, oh, that's token. Okay, so it realizes that if you have a parser returning a token and another parser returning a token, the or else must be token. So that's why that message is slightly better than some of the others. These super nested parsers, boy, they're just tough. All right. I think that's doing it. Modulo error messages. So let's take this up there. That back up here. If input let next on. use it. And let's see what happens. Yeah, it's interesting to me with these. It's almost like you're working from acceptance tests. That it's not. We're not doing a lot of new TDD tests. We're doing some, but not very many, and we're more using the tests we already have. Okay, and let's hope that's 2 errors. Didn't find expected value. That may be coming from the expression thing. On requires at least 1 line number. I think we can make that message generic, and on requires a comma separated list of line numbers. Let's resolve that first. Where's of line numbers? Now there should be like 3 or 4 tests failing. Okay. That one is not. This is one of those. All right, and this didn't find expected value. Oh, that. Okay, let's find that message. I think that's in our match. Didn't find expected value. Find our parser again. Go to if input let next on. Okay. I think this needs a parenthesis. One of these. That's sort of the way you handle the alternatives. If they all get equally far, then let me do it the other way. I can tell you what it's doing now. I think expected go sub and expected go to. Okay. What it will do this way, I think it will go through and try the go to, fail, try the go sub, fail. I think the message will be expected go sub, the last entry. But we're going to give it a default message that says if you get equally far on each case, let's just use the default message. Okay. Which should be this expected go sub. Yeah. So it's, good for me to believe it's working the way I expect it. And since I don't need their messages, I'm going to do this. Okay, that should make all our tests pass. All right, and then the old on should not be being used. Yep. Okay. Oh. Probably could have checked that in first. All right. Let's see next. Print. Okay, I think let's take a look at what we're up against there. Print statement. Okay. Again, a moderate size thing. um, Print is funny. In BASIC, you can separate your printed items. You can just put them print A, B, just a name. And if you do that, they just print in like kind of a spacing kind of thing, a single space. If you separate them by commas, then they do sort of a thin tab, like I forget, every third column or something. And if you do commas, they do thick tabs, which are like every 10 columns. And so it's a little, it has to just kind of read value, value, value. But when it sees a colon, it knows like, oh, there's a new statement coming. We're done with the print statement. So I think we're going to have to, I mean, expression should fail if it's out of expressions. I don't know. All right, I think this one's a little bit more to tackle. Let's tell you what. Let's take a break, like 3-4 minutes, and we'll come back and tackle this print statement. We are getting to the end. There's only print and variable left as sort of the direct level ones, and at that point, just kind of looking ahead, we've still got some wrapolds in here. Expression's the big one. We'll do work on that, but there are a few others out there. So we'll have to go down a level and get them. I think we're closing in though. And then I want to pull this parser. I'd like to pull the statement stuff into its own file. Just it's so much to look at, and this file right now is still, well, it's bigger than ever. Well, no, it's small. I think the original was 760 lines or something. So we've cut down a few lines, but that's still a lot of stuff to read. I don't think we need to do it. So let's do that. We're going to take a break, come back, do the print, and then the variables, and then the rest of the statement stuff, and then move the thing to a file. So I should write that into to do. Okay. We did next. We did on. What else did we do? Let next on. Okay. Right. So we're going to do print. We will convert methods that wrap old calls. Let's see. How about statement oriented? methods that wrap old calls. Once we've done those, we're going to extract statement functions into a new file. And then we'll tackle expressions, which is convert expression to new parser. Okay, that'll give us a plan for, well, I don't think we'll finish, certainly won't finish expressions today. We'll probably make a dent in these others though. All right, see you in 3 or 4 minutes. Bye-bye. All right, welcome back. Okay, let's get on that print statement. Wherever it got off to. Print statement. Okay. So the print parser is match print, and well, it's a list. Okay, it's a list of semicolon, commas, or expressions. And then we got a little bit of semantics to do to put the stuff in. Okay. So it is we could have a semicolon. Match semicolon, which turns into a thin space. Printable dot thin space. Or it matches a colon, which turns into printable dot tab. Or it is an expression which turns into printable.expr with $0. Okay. Self expression turns into that. Okay, so we match that. And these, they're not separated by anything. Okay. I mean, it's a little weird. You don't separate your values by comma necessarily. That's just the way it is. Okay. And then now this stuff at the bottom. Okay, so I think that part should be fine. If you had a colon, you would fail to match expression. So I think we still have this semantics here. Expression won't match end of line or colon, and certainly comma and semicolon won't, so that shouldn't be an issue. Then this, if all that works, this is 0 or more. How can I do that? I guess I'll get an array. Okay. And then the overall value I'm going to say values in, and then this code. This results in a statement. Okay. These two. Yeah, I don't. Okay. So values here is my own array. Seems like we should be able to combine these two, right? If the values count as 0, or this, right? Let's say printables, and then let values, how about var values equals printables. Okay, so this is a list of printables. We'll create a new values array. We can append to it. But I think we could, if the values count is 0, I think we can say this: if values.count equals 0, or it's not a thin space or a tab, then append that. I think that might be equivalent. You know what? I don't need to optimize it at this moment. Let's get it working. Return this, values append. Okay. Let's copy this thing up. I guess it wasn't as bad as I feared, but it's still kind of ugly. I know how important that is. On parser, read parser, so print parser fits here. It's kind of like just enough that I want to, I don't know, I want to do something to it. I don't know if I should extract out this. I'm thinking if I get that smaller, I won't care. See if this works. Interesting. Okay. Now, let's print outputter.output. Extra characters at end of line. Column 27. Oh my gosh. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. Is that what it's complaining about? How did everybody else do? Let's just run the print test specifically, and then we'll worry about the other. That's integration tests, really, so I think it's more of a... okay. Extra characters at end of line. Print with commas. 1 comma this, comma that. Ends in a quote. Okay. 58. 0, 1, 2, 3, 4, 5, 6, 7, 8. Did I not? Characters in the line. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I don't know. It's like I'm not... My old code looked for a colon specifically. Alright, what do we got? Something about the matching. Let's make sure that's that. Okay, so match 0 or more, semicolon, colon, or expressions. So it appears like it's here. Oh. Ooh. Oh no, that... Wait. That should be a comma. Okay, let's go back down to the print statement. And I had that in my brain. Semicolon or comma. Okay. It's sure nice to have the tests already written. 3 failures. Okay. Well, what's up? Start of expression. That may be... I think that's actually a legitimate complaint. Expected start of expression, because we're saying expressions are optional, so it has no reason to know this is an expression. It could be it could be a colon or a comma or a semicolon. So I think that message is actually right for us. And again, it's kind of the difference in the way we're backtracking and that, but extra characters at end of line. It could possibly... Okay, let me, and that's a little awkward that thinks this is the start. I mean, this is a better message. Okay, what else we got? Print, extra characters, end of line. Okay. And so there were 3. Are there multiple complaints? 3 failures. Can I just show failures? Print plus expected start of expression. That is a better message. All right, let's see if we can get that in there. Expected start of expression. And I think this is where, I don't know, it could be a colon or an end of line. Okay, so print. Well, my idea, if you said you could do a peak of match of colon, looking for the end of line, but I don't think it's going to work. Yeah, because this thing needs to be a statement, and it shouldn't produce a statement in that case. Okay, I think I'm going to accept the message, the new message. It's pointing to the same place. Extra characters at end of line. You know, we're identifying the same error. You know, I actually do prefer this for our purposes. Okay. So print is working. Okay, now I want to do this. If the count is empty, or... Oh, I kind of left that in already. Yeah, so if you just append the value, new line, if the count is empty, append new line, and then print that value, that should be the equivalent. Should all pass. So let's see, can we flip the condition if we have values and the last value is thin space or tab, then don't put a new line. I don't know. Let's try it. I'll put a big knot on the front. If values.count, well, is greater than 0, and values.last is equal to thin space or tab. Okay. If the count is greater than 0, and it's either a thin space or a tab, then it's fine as is. Well, let's try make sure I got my logic right. Okay, so I think we could say this is ends with expression. No. Doesn't need. What is it? It's, well, if there are values, well, yeah, needs. I don't know. I don't think that's helping any. I guess I can say it's like doesn't need new line equals this. Well, I guess I just need the inside. That, and if not doesn't need new line, right? Then append it. That's backwards, but flipping the logic, I don't know. Count equals 0. Well, let's try this one. All right, I mean, that should work, but I don't like it. Okay, I could say let needs new line equal this. Maybe format it a little nicer. And needs new line equals values that count equals 0 or values last. I don't know, that doesn't read great either. Well, I know I don't like this one. Let's count as 0 or the last value is space or tab. Let me see Swift sets. Ooh. Let's try that. Can I say this? Yeah. I'm not going to make my things required hashable just for this. Okay. Can I inline? No. I don't know. Does this add anything? Let's make sure it works. Okay. Could I say it equals values.last? I think the thing is I can't say equals. I can't say equals expression because expression takes an argument and I don't know what that's going to be. So that's why I'm balled up. All right, let's move on. Print statement, no one's using. Old parser, basic parser, no direct references. Okay. Is anybody referencing this? Well, this is, let's rename it. Okay, so that really is there just for that. Let's see. That was the positive case. Okay, example successful parse. Let's rename this one too. Example of failed parse. Okay. That's fine. So print is done. And we're working on that last assignment one. Okay. variable parser, yeah, variable wrap old self assign. Okay. So let's go down assign. Let assign parser equal. Well, I think we're going to lose this message is my concern. Expected initial value after equals. Okay. We don't have a match per se. We do expect this to be a token, a variable. Because you got to assign to a variable. Name equals token string. Maybe I should say peak. Okay. That's not so relevant. Variable name. Let's find usages of this. That's used a few times. String. Yeah, we're sure it's a variable at this point. Let's deal with this one. Okay, so let's do our same trick. We'll ignore it for a moment. We'll say let name equal token dot string and see if everybody works. Build fit. Oh, I left junk around again. Okay. All right, so we are definitely getting that from our caller, so we don't need this anymore. Build will tell us where that's used. Unused here. I think that's unused there. Same code. Variable doesn't need it. Okay, that should work. Okay. Okay, assign parser. Is going to be variable. Wrap old variable. Self variable. Followed by and equals followed by an expression. Okay. Our expression. Then we got to check our types and do an assignment. Okay, so variable is actually a kind of complicated thing. Let's go there. It gives us back an expression. All right, however it does its thing. I guess we don't care at this point, but we got to do some semantic rules. So we need to do a check rule that's this. Require matching types. And I think we're going to do something kind of like this. Require matching types. It's going to get, well, it gets the left side, which is an expression, and it gets the right side, which is an expression. So it's a paired thing. Expert is a pair of expressions. Okay. All that is true. Okay, require matching types, left and right. Okay, if it succeeds, I guess that's kind of the opposite case here. I like the positive logic, though, I think better. Okay, if it succeeds, return success, expert. Oh, I'll have to break up left and right. Return success, expert remaining. And otherwise it fails. Failure, we want to do remaining dot start index -1, type mismatch. Dot failure. Okay, and that goes and that goes. Okay. Require matching types. Pulls two expressions. If the left type equals the right type, it's successful. Return the value. Otherwise, we return an error. And that seems good. Okay. Where'd our assignment go? After all those. Assign pipe to this. Require matching types. And then assign otherwise. Okay. We're going to do, I don't think, let's do left-hand side, right-hand side in left hand, right hand side in assign. Cannot enter. This is statement dot assign. Should build. Once again, we'll move this up. Something's funny though, right? We lost this. That may push back. We'll see. This goes up to our parser. I don't know. It almost should come first. Data parser. Let's let assign parser. Wrap bold. Okay, and we need to use it. Run test. I expect an error message test to fail. Maybe more than one. Did I just leave that down there? Okay, that shouldn't hurt anything, but shouldn't affect anything. Oh yeah, we're back to this. Maybe this needs to be require. A variable. Otherwise, I'm pulling this message around. I'm going to say expected variable. Okay. Try require a string. All right. And this will change even more messages, probably. The let is really the one that really goes for it. Oh. Well, wait a minute. Print token. Left paren. What test are we in? Data read tests. Unexpectedly found nil. It's not on the X. Oh, okay. We're getting off by one token thing again. That's the read statement. Sorry, which one was it? It was a read. No, I thought we did read. Go comma list of variables. I'm Variables token type. Try variable. It's something about, in this case, we know, I think it's something to do with the fact that this one's coming through as a recursive descent, and this one is now sometimes called with recursive descent and sometimes called directly. Like our read. Read calls comma list of variables, but our assign calls variable directly. Expected found nil. Column 7. 0, 1, 2, 3, 4, 5, 6, 7. Where was it doing this unwrapping? Inside old parse, comma list. Wait a minute. It says the token type is variable, and we go in there and we try variable. What? Three. Let's see, where are we? This one. Okay. 3, 0, 1, 2, 3. Let's see what. Let's make sure read. I think read had something funny there. On print read, we match the read, and then we go into comma list of variables. And who all is failing? Can't see. Oh wait, why do we have 2 of these warnings? Assign parser was never used. That's extra weird then. Assign parser was used. Assign parser was never used. That one is used. Oh, okay. We don't need this down here anymore. A variable is not a token type. That's the assign. The data test, it's skipping the X. Like, what are we doing that makes it skip that? I'm going to say let's break here, run this test. Variable x, that seems right. Token.strings. So step over. Wait. Oh, requires. Oh, require consumes it, I think. Yes. Yeah. Require. Okay. Okay, yeah. Require 8 the token. So by the time we try to do the variable token, we were already on the next one. All right. And I mean, I could just. Yeah, I'm okay. We may see some expected variables where we had a different message before, especially that let. Oh, turn off my breakpoint. Continue. Okay. We are using assignment. And then this we're using, but assign is no longer used. But it is. Okay. Assign parser. Well, now I don't think I need wrap this anymore. I should be able to use assign parser. Excuse me. If that fails, let is missing variable to assign to. Okay. Okay, so we got one wrappled gone. And let's see, assign. Who's using this? Nobody. Who's using this? Nobody. Okay, make sure those are good. So it was assigned in data. Okay, how are we doing here? Convert remaining statements, print, and assignment. Convert statement-oriented methods that wrap old calls. Okay, I think we're ready to do that. Okay, so in our parser, up here, we still have a number of wrap old calls. And some of them are expression related and we won't do anything with those just yet, but these other ones we will get rid of. But I think let's take another break, again, 2 or 3 minutes, and see you, and we'll come back and finish some wrapping. All right, welcome back. So we're going to get rid of these wrap olds, and right where we were working just now, wrap variable. Okay, so let's see what we have to do. Well, we're going to require a variable. So variable parser is match variable. Okay. Now we have this string type stuff that's there. Okay, my goodness, this is... okay, so you've got the variable, that's the token. If it's not left paren, return something. I think we're going to keep it as a token for a minute. So again, the parser combinator approach tends to like to split out parsing versus semantics versus construction. And this routine is heavy on several of those. Okay, so if it's not a left parend, so that means there's an optional. So it's followed by an optional this. Okay, which will either be a nil or some value. Okay. And what does it match? Well, if it's not left parend, then we come in and match the left parend. Left parend. Well, I don't see how it can be missing if it's an optional. But let's keep it there. Oops. Missing left parend. Okay. We require it, but we don't look at it. The big thing is expression. And we do a comma list of expressions. Okay, so we require it, but don't need it. And then expression is wrap old expression with self, and then separated by match comma. That gets us a list of expressions, and a right parenthesis is next. Right parend, missing right parend. Okay, now that thought we had one that did that. Oh, and. Okay, so we have a variable and an optional list of expressions. Okay, and we're going to pipe that to some code. So it's variable token and expers in, and then we got to do the semantics here. Well, we need this much. Do we use that here? Yes, we do. Okay. Produces a statement. Okay, and then this. Okay, so if expers equals nil, we didn't have any. If there are no expressions, then we have a variable name type. Oh, this is producing an expression. Statement expression. Okay. Else return that. Okay, let's build that. Expers bang. We know it's not nil. Captures variable token. Variable token and expressions. Okay. Now this is actually more part of expression parsing. See if that works. Okay. And yeah, the complexity here is because it could be an array access. All right, so let's find comma variable. I guess that is the first time we saw it. Okay. And we have a wrap-old expression. That's going to be a challenge. Okay. Variable parser. We're going to leave this one for now. No, I'm going to put it in here. Let's do let expression parser equal wrap-old self-expression. So let's move it away from the old way. Well, expression parser. Require variables. There's an expression. Let's see if these are okay. Excuse me. I guess I should move this up. This may be a mutual recursion thing. I don't know. I may be introducing a problem here. Okay, and what else we got for wrap-old? Require variable. We're going to match variable. And assuming that matches, we consume it, we map it to I don't need to say return, map it to $0.string. Okay, we know it's a variable, so it should have that. And I'm going to say required variable. See if we can squeak it on one line. Okay. dim1. dim1, comma list of variables, and that's an expression. Expression's a big job, so that's next time's deal. All right, self dim1. Let's see what dim1 entails. Well, he's non-trivial, isn't he? Okay. dim1 parser equals required variable parser. We already know that's there. And a left parend. Keep the variable followed by, oops, did that again, followed by expression separated by commas. And we don't need to keep the commas around. All right. That gives us an array of expressions, right? Yeah, dim's an array of expressions. We got the name, dimensions, and type for array name. Okay. Yeah, I don't have it in scope. That's okay. All right, what are we doing with it? Well, pretty much this. We get a variable token and expers in okay, and we gotta say array name is we get that already. Array name and these are dimensions. Okay. Okay, dim1 parser, there's dim1. I'm doing something wrong. Variable Oh, variable left parens, dimensions in comma, separated by commas, and then you can have more than one variable. Dim1 parser. Oh no. Fix. Okay. Good. Let's see if this works. Should be good. So much for that theory. Okay. Unexpectedly found nil. Dim-array knows type and size. Well, that certainly looks legit. Okay, so dim a sub 2 should produce a variable a, type array, size 3, 3 entries, all number zeros, and type is number. I think we're getting... Is the problem the globals? It is. All right, let's see if these other tests are doing their thing. And this is another... Oh, okay. Extra characters end of line is not equal to 1742. Extra characters end of line. Line 10. 0, 1, 2, 3, 4, 5, 6, 7, 8. Right parend. Make sure we did this right. Dim1 parser. Yeah, I don't see anything about right parens there. And match right parend. Error messages. Variable is required and didn't find expected value. Okay, we left out a message. Oh, that's a weird place to have it. Function C didn't find expected value. Okay. Let's look at next. That's the easiest. Required variable parser. Mesh variable. That certainly seems like the right message for a required variable parser. Okay. Good. Okay. Okay, so let's find require variable. Who calls this now? Array name dim1, but who calls dim1? Old parser, basic parser, dim1 parser, dim1 parser. Nobody calls the function. Oh wait, they do. Who calls this? Dim old parser. Okay. So I think if I delete this one, it should build. Statement. Oh, whoops. Dim got the old parser. We want the basic parser. Okay, no dim. Dim1. Okay, who calls this one? Nobody. Should build. And who calls this one? Okay. And I think the last, we have expression we haven't cleaned up yet, but I think comma list of variables is maybe it. Comma list of variables, yeah. All right, let's deal with that one. Somewhat straightforward. Okay, variables expression, token type variable. Okay, so this is comma list of variables parser is I'm going to accept a different message again, but mostly we're okay. So it's certainly variable parser. Is it really just this separated by commas? It's returning a list of expressions. I think it's just variable parser separated by comma. A nice example, if true, right? It's, well, 339, 359 would be 20, 18 lines, kind of goes down to 1. I don't know if I can fit it. Yeah, comma list of variables is variable parser separated by commas. Yeah, that's up there. Well, that's so simple. I just want to inline it. Expected variable is not equal to at least one variable is required. Yeah, I think expected variables okay there. And I think another aspect of this is we're kind of combining some things, and um, so these unique messages that are all over the place, they get a little bit more compressed. Oh, how am I doing here? Convert statement oriented method. Yep. Okay. Nobody should be using this. Okay, wrapper tests aren't gone because um, we've still got to do expressions. Okay, but I mean, at its best, this looks pretty straightforward. Like this, or a bunch of one-word ones. And maybe let's move. I think we can move this up here. Okay. All right. And I would say we've done this step. Okay. So next week we'll start with extracting the statement into a new file, just to kind of clean up, keep it a little more simple, just so there's one area for statements and not overlapped with all the stuff for expressions. All right. But I think that whole thing has been pretty good. It's shrinking, not shrunk yet, but we took another 50 lines off. So we'll pick up there next week, Monday, at 1 p.m. Eastern or 6 p.m. UTC. And I hope you have a good weekend. I think next week we certainly expect to finish the whole project next week. All right, thanks for joining today. Hope I catch you in the future, and have a good weekend. Hope it's a long one and a nice one. Bye-bye.